Good afternoon and welcome back to the conference. My name is Rebecca Dikow, and I will be moderating this session, Artificial Intelligence in Libraries, Archives, and Museums, Centering Ethics and Communities. I am a data scientist here at the Smithsonian and work in the Data Science Lab, which is part of the Office of the Chief Information Officer. We collaborate with researchers across the Smithsonian to build and use computational tools to analyze and improve discoverability of Smithsonian data. I'd like to start by thanking the organizers of the Digitization Conference for all the work they put into making sure this runs smoothly. For this panel, we will have 3 short presentations followed by a discussion. As you watch the presentations, please ask questions in the Q&A box, and we will answer as many as we have time for during the discussion. I will give the first presentation describing some of the ethical challenges we face at the Smithsonian in implementing artificial intelligence and other computational tools across our collections and archives. Next, we will have a talk by Mitchell Gordon. Mitchell is a PhD student in computer science working in the Human-Computer Interaction Group at Stanford University. His research focuses on interactive systems and evaluation approaches that integrate dissenting voices into user-facing AI. Next, we will have a talk by Harish Maringanti, Associate Dean for IT and Digital Library Services at the J. Willard Marriott Library. Harish is responsible for advancing the library's technology initiatives, including digital strategy, infrastructure, and innovation. His primary research interests include applications of emerging technologies in digital libraries. Enjoy the talks, and we'll see you back for the Q&A shortly. Good afternoon. Today, I would like to talk about the opportunities and ethical challenges for using AI and machine learning in libraries, archives, and museums. This is a topic that we could plan multiple conferences around. So while this will be in no way comprehensive, I hope to, at the least, highlight the considerations that are top of mind here at the Smithsonian. In terms of opportunities, I will talk briefly about computer vision and natural language processing and describe 2 examples, one from a collaboration with the National Museum of Natural History Botany Department to understand leaf shape and species diversity of ferns, and one from work in support of the Smithsonian American Women's History Initiative to improve the process of extracting text about and names of Smithsonian women in science from our collections and archives. In terms of ethical challenges, I will discuss data bias and describe how historical data are not well represented in the machine learning training data sets used by big tech companies. I will also highlight a particularly problematic use of museum data in an AI application. Finally, I will discuss steps we are taking at the Smithsonian to chart a path forward using AI and machine learning in a way that mirrors our institutional values. First, to the opportunities for computer vision. The U.S. National Herbarium, housed at the National Museum of Natural History, contains more than 5 million plant specimens. The Smithsonian Digitization Program Office Mass Digitization Group has made a huge effort to digitize both images and transcribe labels for these specimens, and there are currently more than 3 million available. Prior to the mass digitization effort, these were digitized one by one, which you can see on the left. Here are 2 examples of digitized botanical specimens. Our team is building computer vision machine learning models that can identify the species of plant in an image. We have a model that can identify very accurately more than 1,400 species of ferns and fern allies. These species identifications can help enhance the metadata for specimens that are not identified. But what we are really interested in from a scientific perspective is understanding what aspects of leaf shape the computer vision model is using to discriminate among species, and how this can add to our understanding of evolution and diversification. Machine learning models allow us to summarize these features for millions of specimens. And what you are looking at here is the plot of fern morphospace, which is a way of looking at all the ways of being a fern in one image. On the left, the warmer colors indicate fern shapes that are the most species diverse. These models allow us to look at global patterns for thousands of species, which would not be possible without this machine learning technology. This work is being led by Alex White, a data scientist in our group. A second opportunity is in the area of natural language or text processing. As part of the Smithsonian American Women's History Initiative, we are using machine learning tools to more accurately extract women's names and mentions from diverse collections and archives. An example illustrating the need for this work is the case of Mary Walcott, a naturalist and illustrator from the early 20th century. Tiana Curry, a summer undergraduate intern in 2019, found instances where specimens collected by Mary were attributed to her husband, Charles Walcott, a paleontologist and Smithsonian secretary. Highlighted in the red boxes are labels where you can see Mary's name written out, either as her full name on the left or as Mrs. Charles D. Walcott on the right. Here's a close-up view of these labels. Both of these specimens were collected after Charles's death, so we can be quite certain that they were both collected by Mary. Because Mrs. with the husband's name is very commonly found in our collections and archives for many women at the Smithsonian, we are building custom tools to make sure we extract not just first and last names from these collections, but also preserve the honorifics, in this case, Mrs., but also sometimes Ms. or Miss, so that we can more accurately capture the mentions of women. Finally, here's a mashup of labels from many different specimens collected by the Walcotts. Machine learning tools can help us disambiguate who collected which specimens and make sure they're attributed correctly, and to do this at scale. Next, I would like to briefly talk about the ethical challenges that come with using and building these tools. The four that I will touch on are data and algorithm bias, the potential to harm our visitors, the lack of representation of historical and cultural heritage data in training sets, and the environmental impact of this work. I would also like to point you to the work of inspirational scholars Kate Crawford, Safiya Umoja Noble, Ruha Benjamin, Tinmit Gebru, Joy Bolomwini, and many others whose scholarship is essential to building an ethical future for AI and machine learning. These works are helping us at the Smithsonian chart a path forward. First, a few words about data bias. Data bias might be something we most naturally think about in terms of human-related data. A museum might have, or will definitely have, more paintings of white men than of people of color. So any inferences we make about people in those paintings are not going to represent reality. But I think it's important to note here that bias impacts all of our data and must be considered in every computational project. Here is a map from the Global Biodiversity Information Facility showing the Asterales, which is the order of plants that contains sunflowers and daisies. These are specimens plotted on this map from our National Herbarium. You can see that globally our collections are uneven. So in a way, our data are biased in terms of where we've collected these plants from. Data bias doesn't have to be nefarious. It can simply reflect either the interests of the researchers working in the herbarium or where it is most convenient to travel to. But regardless of the reason, any model we build based on these specimens will also reflect this data bias, and we need to document it as thoroughly as possible. A related issue with consequences for museums, libraries, and archives is the fact that AI algorithms that we interact with most commonly, for example, Facebook suggesting certain friends to tag in our photos, or our phone showing us all of the photos of cats in our image library, these models are not trained with historical data. Here is a daguerreotype camera from our National Museum of American History. If we pass it through the Google Vision model, which provides labels for any images you upload, you can see those on the right, what Google Vision thinks this object is. It's not accurate. This is not terribly unexpected. This is a somewhat maybe obscure object, but it's really the tip of the iceberg because historical accuracy and nuance is central to the work that museums do, and inaccurate labels have the potential to harm, particularly if they're related to sensitive topics, which many of our collections and archives are based around. Finally, I wanted to mention this paper that came out in 2020 as an illustration of how not to use museum data. In this paper, researchers extracted the features from faces in paintings from the year 1500 to 2000 and gave them trustworthiness scores and looked at these scores and how they changed over time. This paper has numerous flaws, and there is a statement of editorial concern about it, but it is still currently published. Given that the data are skewed heavily toward white people, and most importantly, because an algorithm like this has the potential to be misused. It could be used to determine trustworthiness of people in real life situations based on their appearance. To me, this kind of work illustrates very plainly the fact that we in the cultural heritage sector need to think very carefully about how our models might be used in the future. Just because we can doesn't mean we should use these computational tools in every scenario. Given all these challenges, the path forward has to be collaborative. At the Smithsonian, we are working to build a community of practice that includes subject matter experts from across the institution. We have a reading group where we engage with the critical scholarship around AI ethics and working toward developing the framework under which AI and machine learning can proceed while acknowledging both the risks and potential opportunities. At the heart of this is a set of questions that should be asked of any project going forward. Were the data collected with the consent of the subjects? What is the resource consumption of the model training? And do these environmental impacts fit in with our institution's climate goals? What biases exist in our training data? What are the end goals of the model? Does it have the potential to harm either our visitors or other communities? Are the communities that could be impacted by this model implementation, are they participants in the model development? I'd like to thank colleagues across the Smithsonian for their interest and engagement in this topic, and members of our OCIO Data Science Lab, in particular Mike Trisna and William Mattingly. And I look forward to answering your questions during the discussion. Thank you.
Hi, I'm going to talk about how we design machine learning models when annotators disagree on what the right answer ought to be. Imagine you're training an AI model to remove toxic comments from an online community. Should this training example, which is making some aggressive comments about religion, be an example of content to remove or an example of content to keep up? This is a tough one. It turns out that in the public dataset we took this from, half of people feel either way about this comment. So in today's typical supervised learning pipeline, we then model a sort of aggregate pseudo-human, predicting the majority vote label while ignoring annotators who disagree with the majority. Or maybe you could do a bit better and decide that your AI should predict a 40-60 distribution. But if you're a practitioner who's then got to decide whether to remove this comment or not, what do you do with that information? There's not really a good answer. So let's ask a different question. Whose voices is our model emulating here? It turns out that if our training data were labeled entirely by white males, the distribution slightly tips towards leaving the comment up. But if our data were labeled by groups that are often targets for online harassment, like women or Black individuals, you'd see the distribution swing towards labeling this comment as toxic. And voice matters. Healthy spaces and communities have their own distinct norms and values. Non-parents shouldn't decide which topics are fair game in a parenting forum, and the political problems taking place in the Star Wars universe require a very different standard of discussion than those taking place in a forum on Saudi Arabia. One model trained from one dataset won't fit all these communities, and just as importantly, nor will it allow for an opportunity to figure out what will fit. Because today, whose voice the AI emulates is a decision baked into this training data here and then swept under the rug in AI systems. As a result, for many practitioners, the answer of whose voice their AI is emulating is left implicit within the data collection and training procedure. In this talk, I'm going to introduce jury learning, a supervised learning architecture, a technical and normative approach that lets practitioners articulate exactly the voices they want determining the behavior of their classifier, and in doing so, often changes an AI's predictions. This is an important problem because in user-facing tasks ranging from not just toxicity detection, but also from poster design to cancer treatment, 1/3 of experts disagree with a typical decision. So if we could make voice explicit, we could also weight treatment opinions from doctors with particular expertise, or select design decisions from designers trained in a particular school of thought. Or maybe a practitioner isn't sure who to side with, and they could reason over the decisions that different people would make. What we need, and what our research introduces, is an interactive system where when annotators disagree, we can choose which voices our classifier listens to. So how could such a system be possible? Well, here's our key insight. Datasets are ultimately made up of individual people. So instead of modeling some aggregate pseudo-human, let's model individual people. We're going to demonstrate that it's possible to model individual voices in your training dataset, enabling us to then design a system for interactively exploring, tuning, and shifting the behavior of the classifier by explicitly choosing which annotators our classifier will emulate in what proportion. Let's walk through the jury learning architecture. Given an input, practitioners start by defining a jury composition, selecting from characteristics in their dataset. For instance, if a dataset contains each annotator's political leanings, then the practitioner can say they like, for instance, 2 liberal jurors, and for this example, we'll also choose 2 jurors who are parents with high school diplomas. And we now have these 4 empty juror slots, and we need to choose individual annotators from the dataset to fill them. So we'll start with all the annotators in the dataset, and again, these are real individual people, and just like in any typical dataset, they've each only annotated some small subset of the examples in the full dataset. And then we can filter to all of the relevant annotators in our dataset. Jury learning currently requires that datasets contain these explicit labels about annotators. And we then randomly select a matching annotator from the dataset to fill each juror slot. And the AI then predicts how each individual juror would vote using all the data we have about their annotations and the annotations of other similar jurors, giving us this jury's verdict. I'll talk about the model architecture that powers this in a minute. And of course, this can work with regression too, where we predict a numeric value instead of a yes or no class. So randomly selecting one set of jurors gives an idea of what one particular set of people might think. But jury learning enables something that was impossible with real-world juries, which is we can resample jurors many times, creating many parallel juries. And then each parallel jury has its own predicted verdict, and so we get this distribution of jury verdicts. Each dot is a resampled jury. And then for a single final decision, we can take the median, giving us a median of means estimator. And by modeling individual annotators, we've enabled interactive sense-making about the nature of disagreement. For instance, we can plot the distribution over our model's predictions for every annotator in the dataset who we could have chosen as a juror versus our model's predictions for the actual jurors we selected, showing us that, for instance, Democrats are far from monolithic in their views about this comment. All right, so that's the interaction. Now, walking back to that prediction step, how can we predict each annotator's response to some unseen example? Well, we assume that we have a typical classification dataset. Each of these jurors are, again, just annotators. And like a typical dataset, we assume annotators have some mostly disjoint, occasionally overlapping set of training examples they annotated, and a bunch of training examples they didn't annotate. And of course, we have this not just for annotators we selected as jurors, but for every annotator. And for every annotator, we have a bunch of characteristics. And then what we want to predict is each juror's response to some unseen example. So to do that, we designed an architecture that co-trains a transformer-based text classifier to use as content embeddings within a deep and cross-network recommender system, which learns embeddings for each annotator and characteristics. And our technical evaluation found that this architecture achieves state-of-the-art performance. All right, so before we continue, it's important to make clear that while we view jury learning as a step forward, it is by no means a panacea. It will create or at least bring previously hidden problems to the forefront. One challenge Jurors can be biased. For instance, selecting a woman doesn't necessarily mean you're getting a juror who supports women's rights. Our perspective here is that there's two orthogonal and complementary worldviews. Today, most approaches assume that the world or their data set is broken and then applies post-hoc statistical transformations to try to de-bias model outputs. With jury learning, we're saying that it could also be really useful to select or train the people whose voices should influence the model, because it's often more tractable to do the latter. A second consideration, who determines the jury compositions? Well, let's first note that every dataset already has an implicit jury. They already have some existing distribution of annotators who end up influencing classification decisions. What jury learning does is make that fact explicit and visible and easily changeable. It provides a new way to communicate and debate whose perspectives are being included. Our take is that when using jury learning, practitioners should make jury compositions transparent and provide stakeholders with a voice in selecting them. So now I want to touch on our field evaluation. We gave jury learning to 18 moderators, and one question we asked is, do moderators author juries that are more diverse than the composition of a typical data set? And here's what the composition of a typical data set looks like. It is 74% white. But we can see here that when we gave moderators jury learning, they chose to create juries that represent a much broader cross-section of society. Another question we can ask is, do the predicted verdicts of juries composed by moderators make different decisions than a standard state-of-the-art classifier? We found that 14% of classification decisions changed, and that the most likely to flip were comments that were the most divisive. And these comments on the edge are really important because behaviors in edge cases often become de facto platform policy. So that was jury learning. We hope that when annotators disagree, jury learning empowers practitioners to make explicit, carefully considered choices about which voices their models reflect. Thank you.
Greetings. Thank you for the invitation to join this panel. Today, I'm going to talk about our overall approach to AI and how it has evolved in the last 3 years at University of Utah. Given the focus of the conference, which is on digitization, I will begin by talking about the types of collections we have at Utah, and hopefully that will set the stage for the rest of the presentation. Next slide, please. At our university, we have thousands of manuscript collections, thousands of photograph archival collections, including the one that's shown on the top right, which is Kasai collections, an important collection from the underrepresented groups. Mr. Kasai, for the folks who do not know about him, he served almost 30 years in the United States Military Intelligence Service and became an activist for the rights of Japanese Americans. We also have an important Utah ski and snowboard archives. The logo is shown on the bottom right. It is one of the most comprehensive collections in the entire country for research into the history and development of Utah's prospering winter sports industry. Next slide, please. We digitized a few of these collections. One of our well-known and popular collections is the one shown on the right. It's the Arabic Papyrus, Parchment, and Paper collection. It is one of the largest of its kind in the United States, containing over close to 800 Arabic papyrus documents, 1,300 Arabic paper documents, and several pieces on parchment. But one of our biggest digital collections is the Utah Digital Newspapers. Right now, it has over 18 million articles and close to 4 million pages. And we have coverage going all the way back to 1860s when the first newspaper was published in the state. Next slide, please. So even though we have digitized a few collections, we have a lot more way to go in terms of cataloging and digitizing our other collections. Our initial explorations for AI started with the goal to perhaps create tools to assist our curators and archivists in processing these collections, and also in making sure that we can speed up the process of adding metadata for discovery. Next slide, please. So rather than talk about individual projects today, I will talk about our approach to AI in general and how we are shifting our strategy to focus more on working with different groups to understand data and involve them in model building where possible. In the next few slides, I'll talk about 3 specific projects just to demonstrate that shift in our strategy. Next slide, please. So our initial entry into the machine learning space began with a project where we used off-the-shelf machine learning models to test whether we can generate relevant tags for our historical images. And these are the results that we found, things where it did not work out well. As you look at this image, consider that image, which is captioned with the model trained on the MS COCO dataset. Not only do the captions misidentify the people in the picture, there is a clear anachronism in the generated captions. And it occurs because the data that was used to train the captioning system contains modern images that are digital first. Directly employing such models on archival images will lead to a modern bias in the generated captions. Let's look at another example. Next slide, please. Kabuki Theater, for folks who do not know, Kabuki is a form of classical theater in Japan, known for its elaborate costumes and dynamic acting. The captions that you see on the right are machine generated, and they are insensitive, if not completely offensive for certain groups. And this is what we call the representation harm, which happens when a system perpetuates stereotypes and power dynamics in a way that reinforces subordination of a group. After these two, next slide, please. Based on these initial explorations, it was pretty clear that we were dealing with the problem of domain adaptation. It's a well-explored problem. In addition to this problem, where, again, trying to use a model that was optimized to predict accuracy on one domain, which is the everyday images that were captured with, say, the cell phone cameras, it doesn't work properly for another domain, which is archival scans of black and white photographs. But in addition to this, there was also a problem where certain concepts in our collection simply do not exist in benchmark data sets, because the 2 sets of images are from completely different timelines. Given this, we started, next slide, please. Given these initial hiccups, we wanted to pause and understand our own machine learning pipeline, audit the pipeline, and identify places where biases could creep in, and understand what sort of intervention methods we could develop to prevent such biases. Right around the time when we were auditing this pipeline, next slide, please. Interesting research papers came out. This one is from MIT, Harish and John Gotag. They proposed a framework to identify sources of potential harm. And in addition to this paper, a couple of other papers that Rebecca cited in her presentation too, one from Timnit Gebru, talking about lessons from archives, how to gather data for machine learning purposes, right? Those have become the templates for our own understanding. Now, based on this research, based on our own auditing, we changed our approach and shifted our strategy slightly. So in the next couple of projects, we would talk about how we shifted that strategy. Next slide, please. So this is a project which we are actively engaged with the research team. This is about the Southern right whale archival project. It's the longest continuous study of large whale species. The data goes back to 1970s when it was initially captured. Next slide. The foundation of the project is on identification of these whales. And the way that's done is by looking at the callosities where they appear, how many, etc. Next slide. All that information is captured in field notes, in Microsoft Access database, and a bunch of other citing maps. Next slide, please. So we are working with the researcher and the team to understand how to capture the data, how to curate this data so that it can be made available for further machine learning explorations. One of our objectives is to work with the research team and build a machine learning based identification system. Right now, it's a very intense process, and we hope to make the data available and work with researchers to make it available. Next slide. So in this project, again, our emphasis is on working with the community, working with the research team to understand the data practices. Next slide. The last example here is the Native American oral history collections. Right now, our focus is on creating a word bank and topics and use Google's AI framework to understand how we can work with different tribal groups in creating a set of tools that they then can use to understand their own data and decide for themselves whether they want to share it with their own tribal communities or publish it for the general public. So the two active projects are focused on developing a list of words that are problematic. These oral histories were recorded back in 1970s. So some of the words that were not problematic back then could be now. So we are working with the tribal communities to develop a list of problematic words and run through the AI scripts to identify where such problematic words appear, both in the original transcript and the modified one. And also to recommend a list of topics that they can then identify and decide what can be done. For example, in certain tribal communities, there's a norm that certain stories can be shared only during winter time, right? So we are working with the community to understand these practices well. Next slide. Again, these projects are helping us understand how to work with communities so that we don't directly dive into the AI development work, but capture the context and get the data ready so that we can engage with the researchers and other teams to get this work done. I will conclude this presentation here and pass it back to Rebecca for Q&A.
Thank you, Harish, and thank you, Mitchell, as well for your talks. One first question we have, and I'll send this first to Harish and then to Mitchell to get your comments. What do you see as the role of industry, if any, in solving any of the ethical challenges we discussed today, given that we gave some examples of kind of the off-the-shelf tools not working properly? What do you see as that kind of going forward for industry?
Again, for this part, you just want to make clear, this is just my opinion, right? I'm not sharing the views of my university. From my viewpoint, I think if the community as a whole, if the market shifts its incentive system so that we value not the first movers in the market, but the trustworthy players in the market, I think that would be helpful. One observation is the farther the folks are from the data, the simpler it becomes to violate these norms, right? So the process would be, how do we remove those barriers and get both the industry partners and whoever the researchers are closer to the action, closer to the data. So I'll pause there, Rebecca.
Thank you. I totally agree that I think what has made the idea of applying AI to our collections and archives at the Smithsonian feasible, even in the very least, is because we have so many experts who are so familiar with the data and allow us to really think hard about potential biases before we start anything. And I agree that it would be wonderful if industry saw an incentive in doing that as well. Mitchell, do you have any comments on that?
Yeah, thanks for your question. So the point of jury learning is to, or so the argument that we're making is that we should be empowering the people who are creating classifiers to explicitly choose whose voices those classifiers are reflecting, whose voices their AI is reflecting. And I think that companies have a lot of incentive to want to do that themselves. Companies, when they're creating products, they very often want to know, or they want to be explicit about who they're building their products for, about who their products are useful for. And so certainly for many tasks, you can imagine that companies will probably want to be able to use something like jury learning. So I think it's less about sort of incentivizing and more about just giving them sort of making sure that they understand the problems that they have today and giving them the tools to actually solve them.
Thank you for that. Another question, and I'll go first to Harish again. How can smaller institutions begin to tackle these challenges? I think they can seem enormous, I think, for maybe, when compared to industry with, hundreds of data scientists, we're smaller organizations that don't have a huge staff devoted to this work. How do you think they can kind of start making it happen?
Yeah, good question, Rebecca. Again, sharing my own thoughts here. I think one of the important things to recognize and understand is contributions to AI can happen anywhere on the spectrum, right? So someone doesn't need to have data scientists on board to do the model development, right? A lot of work happens even before the actual evaluation and model building work begins, right? We talked so much about the data. And smaller institutions, presumably, if they are closer to the data, I think they are the ones who can work extensively with the community members, right? The source of the data, right? I think there are ways in which even smaller institutions can contribute to the overall discussion and identifying how the narrative could be shifted so that the attention is put both on pre and post what we call the model development work, right? Even once a model is developed, so much needs to be done in terms of making sure that it's monitored for model drift and other things too. So again, given the resources that I have at our own institution, which falls anywhere between a well-resourced versus a not a well-resourced organization, right? We do have access to researchers, but we understand that we cannot do everything on the AI cycle, right? Accurately. So I think that's where we shifted our focus to see how we can optimize the limited resources that we have by focusing on these important critical steps.
Great. Mitchell, I have a question for you. How do you, and maybe it's selfish because we're thinking about this a lot at the Smithsonian, what are some ways that we might, start doing a better job of documenting the bias in our data, or the ways that we are trying to kind of correct for it in our kind of data work before building models or during the model building process? If you have thoughts on that.
Yeah, that's a great question. So I'll start by acknowledging a lot of the great existing work. I think you even cited some of the great existing work there in your talk from people like Timnit around data documentation, being very careful and explicit about how you're collecting your data and documenting how you've collected it. And so that is certainly an important first step. And then what my work is trying to do is say that, well, often, and this is sort of going back to the earlier question that you just asked, often these smaller institutions maybe don't have the ability to collect their own data set. Maybe they just have to use some off-the-shelf data set that someone else has already collected for them. You see that's often what's happening. And as a result, whatever decisions were made when collecting that initial data set are the same decisions, they're the same design decisions about whose voices are reflected in that data set that every subsequent user of that data set is going to use. And they often might not even realize that, because they didn't collect the data set. Sure, there's maybe some documentation, but it's hard to really understand exactly whose voices are being reflected in a data set, especially if you didn't collect it. And so the position that jury learning is advocating is that when we collect data sets, we should be, it's a great first step to sort of just document generally the high level statistics that existing approaches suggest. But we're arguing going a step further and documenting within the data set itself salient characteristics for every individual annotator. And in doing that, you can then model each individual annotator, and you can then, for any particular application, choose which voices are being listened to and which voices are not being listened to in a way that doesn't require an institution to necessarily collect their own data set. You could still have just one large data set that some resource-rich institution has collected and makes public, but smaller institutions can then have the ability to explicitly choose who's going to be used, whose voices are going to be used and whose voices are not going to be used in their specific application.
That's great. I think that's a wonderful idea. I think that could be really, really useful. Another question for both of you is how can we think about scaling AI or machine learning at cultural heritage institutions? Or how do we kind of balance wanting to scale things with the need for a lot of custom data work on individual collections and archives? I don't know that we'll come to an answer, but just kind of if you have thoughts about that. Harish, would you like to go first?
Sure. I think some of as we go on this journey of AI work, we are able to ask some very important questions, I think, Rebecca, including whether whether there is a role for AI, and even if there is a role for AI, whether we should be using it in the first place, right? I think you captured it in one of your slides towards the end. So in terms of scalability and efficiency, I think I look at it as an acknowledgement that there are other bigger and important problems to solve. There needs to be an acknowledgement that all these technologies can have broader societal impact, right? And again, efficiency and scalability is important, but it needs to be grounded in the context where there's nothing like causing little harm versus a lot of harm to the underrepresented groups, right? If it is causing harm, perhaps we shouldn't be using these technologies in the first place, right? So I think in my own journey and in our own internal discussions, what I appreciate about the ongoing conversation related to the impact of AI on ethics and communities is some of the important questions that should have been asked before that were never asked are at least being asked right now under the lens of AI. So AI has given us an additional lens to view our own work and reflect on what needs to change. So the end result could be whether we are using AI or not using AI. I mean, that probably would be a mute question. I think the important question is how has it changed in terms of our own internal workflows and practices? So I think it's, again, I have a different spin on that question, right, on the scalability and sustainability. So, but I would love to hear your thoughts too, based on the work that you're doing at Smithsonian. Obviously, scalability is something that I think you would be interested in. So I wondered how you are approaching the same.
Yeah, well, I don't know if I have an answer, but I think it's just something that we're thinking a lot about as we kind of are spending a lot of time gathering ideas for potential projects, things that we could, try automatic OCR on and maybe optimize models for a particular use case. But how are we thinking institution-wide about making these tools available to researchers so that not every project needs a data scientist collaborator. And so, yeah, I don't know if I have a good answer, but it's just interesting how much custom work we're doing on every single project, and how just thinking about how going forward, how much that will that always be necessary, or will we try to kind of come to shared, a couple of shared infrastructures that work for different kinds of data, or different museums maybe kind of can kind of work together. But the Smithsonian is, such a wonderfully diverse institution that it just provides a lot of data challenges that we find very interesting, but also a little bit daunting sometimes. Mm-hmm. Mitchell, do you have thoughts about this as well?
Yeah, you guys both gave great high-level answers, so I can try to give a sort of specific example of what we did in jury learning to address this challenge. So in machine learning, there's a lot of great researchers working on techniques that are called transfer learning or multitask learning, and those are techniques that essentially are designed to help you try to take a data set or take a model that was designed to do one thing and then learn something from it for a different task. The goal there being to try to let you collect a potentially smaller data set for your specific task, and while sort of taking advantage of the work that's already been done for some related but different tasks. And in jury learning specifically, what we did is we had this data set for toxicity detection, and this data set contained characteristics for every single annotator. But because collecting such a data set is kind of expensive, it wasn't necessarily large enough to train a highly performant model on its own. So we were able to borrow another very large data set for toxicity detection that didn't have these characteristics, and use it to do something called pre-training. We were able to pre-train a model that was kind of good at toxicity detection in general, and we could then fine-tune that model using our own data set. And that's just one sort of technical example of how you can use existing data sets. But more generally, that's an approach that I think is going to be really important, not just in the research community where it's popular right now, but more broadly in industry too going forward.
Yeah, that's great. And for our botany project, we definitely use transfer learning to build our species ID model. And yes, it makes things a lot more tractable, I would say, for researchers. Great. Let's see if we have any other questions. Oh, yes. How do you think AI can and will change the fundamental scientific study of collections in the future? I can try to take that first.
Yeah, I'm gonna have to hand it off to you guys, but I'm curious to hear what you have to say.
Now, for us, I think we're always really careful to say we don't think it will. We're not replacing curators with computers, right? Like that's never going to happen, and it wouldn't work, and it wouldn't be desirable at all. But I think we've been thinking in terms of the scientific work with the botany collection, and we've done some with entomology and some with the Conservation Biology Institute in identifying Amazonian fish as well. But we kind of see two main areas where we can use machine learning to improve the scientific workflow. And one is kind of from a curatorial perspective, that we can improve the metadata for specimens that may not have a lot of metadata using AI tools. And for the botany example, we developed a species ID model that we ended up wanting to use to look at morphology. So we're sort of interested, well, we wanted to be accurate in identifying species, but that wasn't the end goal. The end goal is we're interested in understanding shape. But we can use that species ID model to at least put probable species IDs on any specimens that don't have identifications. And so for for Smithsonian collections, which are, very large, millions of insects, for example, if we developed a similar model for insects, we could, add labels, which again, we could add a field that says this is a machine learning generated label. It might not be accurate. Someone should go in and check. But it at least would provide a way to make the data maybe public faster so that we could get expert ID later. So that I think is an efficiency thing. But in terms of actually studying the collections, we're interested in looking at how we can compare what the computer is seeing as distinguishing one species from another, what aspects of the shape, which is what our data scientist in our group, Alex White, is working on, understanding what aspects of the plant shape the model is looking at when it's deciding whether it's one species or another. And that's something that we can compare to more traditional ways of looking at plants, measurements, or traits that botanists look at by eye. So I think there's not necessarily one right way to do it, but I think that comparison could give us maybe potentially insight into new traits that hadn't previously been considered important or distinguishing across species. And so that I think is kind of a second way that we see these tools helping with studying collections. And I'll admit we haven't worked with that many yet. So I imagine as we get into different biological domains as well, there'll be even more avenues that we could go down. So again, thank you to the Digitization Program Office for digitizing all those botany specimens, which are an absolute dream to work with because they're two-dimensional. And yet most of the information is captured. So they're just a great data set. But Harish or Mitchell, do you have any thoughts about that question as well?
I can't think of anything else to add to what you stated, Rebecca. One of the projects that, again, I covered in the presentation very briefly was about this Southern Right Whale project, where our hope is if we accurately capture the current data practices, right? It's spread across many different segments right now. Part of the data is in Microsoft Access database and field notes and etc. So our hope is once we centralize it and digitize it and make it available, hopefully some of the new research scholars would ask questions that we cannot even think of right now, right? That is the beauty of these data sets. So yeah, on the scientific angle, I think that's where we are focused, mostly on how do we work with researchers in bringing some of the legacy collections into new light. So more interesting questions could be asked of the data set.
Yeah, that's great. And something I kind of forgot to say, although it was sort of in the talk, was really just about summarizing if you have millions of specimens or even hundreds of specimens, being able to summarize aspects of them visually, I think is something that previously just wasn't as possible. So I think the kind of tools to reduce, to allow kind of multidimensional information to be presented in two dimensions, I think will hopefully also kind of spark new research questions. Being able to look at all the data transformed a bit, but look at it all in one place, I think is something that's really exciting in terms of science. Mitchell, did you have something you wanted to add?
I am completely new to the application of AI in this collection space, but it's been really interesting to hear you guys discussing it. I've learned a lot just from that. And one thing that's occurred to me that's kind of interesting about this space is, unlike in other domains where you can usually generate more training examples if you need them, there's sort of in many cases in the collection space an inherent limit in just whether more training examples exist because they were generated slowly over a long period of time, at least in some tasks. And so that strikes me as a particularly interesting constraint that I haven't thought much about before. I don't know if I have much to say about that, except it seemed interesting. I'd like to think more about it. I'd love to hear if you guys have thoughts on that.
Yeah, no, I think, sorry, I was unmuting. I think that's a great point, and that's something that is challenging as we kind of dream up all the potential projects is, well, you know, what's digitized, what's not digitized, and then even if it is digitized, how many of these do we have? And that's something that with the Botany project, we've also been thinking about kind of benchmarking how many specimens per species we include in the model. So initially it was like, let's only include species with, you know, 500 images each, but we know that that's not realistic for most collections necessarily, or in other institutions that don't have, and we have lots of, you know, species that we may not have that many images for, but we would like them to be included. So I think a lot of work still needs to be done in the area of kind of seeing what those limits are. And I know with the newer models, it's definitely more and more achievable to have fewer images per class in computer vision. With text data, we can probably do a lot more of generating different versions of older texts. I know one of our postdocs, William Mattingly, has been working to do some of that, as experimenting how to kind of improve OCR for some of these older typewritten documents with really bad fonts to transcribe. So thinking creatively about how to augment data, I think, is something that we need to do a lot more of. Did you want to add anything to that, Harish? Sorry.
No, I just thought of a question for Michelle, if we have a couple more minutes, Rebecca.
I think we have 2 more minutes. Yeah.
Yeah. Hey, Michelle, thanks for sharing your research. As I was looking at the report, reading through the report, one question that came to me was, so the annotators, right, the way they express their values is, it's a self-reported data, right? So is there a way you can account for any biases that would creep in because of the self-reporting aspect? Because in reality, they may act out differently when presented with a real situation, right? So I wondered how you approach that question.
Yeah, absolutely. That's a really great question. Yeah, that is, you know, there is this inherent limitation of data sets when there is self-reporting happening. And there's certainly a lot of great work, not just in machine learning, but going back decades in sort of people studying how to design surveys or how to collect data around how you can overcome some of those limitations. And you could certainly imagine some of those approaches being used to collect jury learning data sets, but ultimately there are going to be some characteristics that you care about that maybe you just have to rely on self-reported data. And yeah, our project sort of isn't saying we're going to be able to solve every aspect of machine learning, because ultimately we are still reliant on whatever limitations your data set has. And so there's no substitute for, you know, once you've used jury learning, once you've created your model, actually, when you deploy that model, make sure you're evaluating it with the stakeholders who matter, and make sure that the model is doing things that make sense to those stakeholders. Just sort of ensuring that you're not just stopping at saying, well, we've collected a data set and we think, you know, we have exactly what some group of stakeholders want, so we're done. We've done our job. You can't stop there. You have to sort of continue to do a good job of evaluating your model with the stakeholders.
Yeah, thanks. Thanks for that, Michelle.
Thanks.
Great, and I think we have just a few seconds left. So I'd like to thank Harish and Mitchell for being here today and for the great conversation. Feel free to send us questions in the chat. I'll be looking at it after this if anything else comes up. But thank you again.